Okay, so for 6-6, there are two different parts. There's trapezoids and kites. Make sure you write down both parts. So first up of trapezoids, it breaks it into two different types of trapezoids, just trapezoids in general, and then specifically isosceles trapezoids, okay? So first up, we have trapezoids, which a trapezoid is one pair of parallel sides called bases. Okay, now this could also be turned sideways. The bases don't always have to be on the bottom. And then a pair of non-parallel sides called legs. So this is different than a parallelogram because these two sides are not parallel. Okay, so we know it's different. This is just another type of quadrilateral. So the first up, the legs are supplementary. If we think about it, parallel lines cut by transversal, these are same side interior angles. But unlike with a parallelogram, remember on a parallelogram, A and B were supplementary, but so were A and D. That's not the case on trapezoids, which is very important to remember, okay? These two base angles, they don't relate to one another in general with trapezoids. We'll get to isosceles trapezoids here in a moment. And then I want to talk about the trapezoid midsegment theorem. Okay, so if we remember midsegment from 5-2, a triangle midsegment cut two sides of a triangle in half and was parallel to the third. I really wanted you guys to recognize that language because midsegment in a trapezoid cuts two sides in half and is parallel to the other two sides. So it has to cut the legs in half because the other two sides are already parallel. Now, the really cool thing about trapezoid midsegments, if you remember, in triangles, they were half of the side they were parallel to. Well, trapezoids are parallel to two different sides. So we have to add those two sides together and then divide it by 2, and that's how much the midsegment equals. It's very important to recognize. Triangle midsegment. Add up RA plus TP, divide it by 2, that's what MN equals. So you'll use that as well. Then we have isosceles trapezoids. A trapezoid with congruent legs. That's very important. We've got a set of congruent legs, which means whatever this is going to equal, this is going to equal the same. Notice these are not the parallel sides. This still isn't a parallelogram, okay? And on isosceles trapezoids, the base angles are congruent. So in general trapezoids, these two angles don't relate at all. If we only know one angle in a regular trapezoid, we can only find one other angle. In an isosceles trapezoid, if we know one angle, we know T and P are going to be the same, but we also know that the leg angles are supplementary. So we know we could subtract T and P from 180 and get R and A. They're going to be the same as well. Okay. And on an isosceles trapezoid, just like with a rectangle, isosceles trapezoid diagonals are congruent. So we can set those two equal to each other. Okay. So that's trapezoids. So there's a lot to write about trapezoids. But then we also got kites. Okay. So these are the last type of quadrilaterals we'll learn about. And if you go to the poster section of my Canvas page, you'll see a poster all about quadrilaterals. So kites have two pair of consecutive, remember consecutive means next to each other. So this pair, they're congruent, and this pair are congruent. So two pairs of consecutive sides congruent. It's very important. Now, the angles formed by non-congruent sides are congruent. So we're talking about not I and E, but K and T. Those two angles are congruent. And what I want you to think about is think triangle. So we drew this dashed line down in here. If we draw that dashed line, well, then I can prove that these two triangles are congruent by side, 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 because they share the side with the reflexive property, right? Which means these two angles are going to be the same. So that proves that kite, two angles are congruent. Two sides congruent. So now that we know that those two angles are congruent, that means that this imaginary line that we drew in here is also an angle bisector, which means it cuts E in half and it cuts I in half. But it doesn't mean that E and I are going to equal each other. That's not how that works. Then this would be a rhombus. Okay. Another important thing, and this is actually very similar to rhombuses, is that the diagonals are perpendicular. So that diagonals still form a 90-degree angle. So we can still use that to find the measures of angles. Okay. So kites and isosceles trapezoids steal a few of their facts from rectangles and rhombuses, but we got to keep in mind that's not quite the same thing, and to be looking for those key differences throughout. Okay, so that is what 6-6, and let me show some example problems about it. So first example problem, we can see we have an isosceles trapezoid, and we can look at what we know about isosceles trapezoids. Well, it had one pair of parallel sides, one pair of congruent sides. Well, we know on an isosceles trapezoid, the base angles are congruent. So if this is 65, this is 65. We can always recognize the bases, and it may be handy to even write it on there to just say, hey, the parallel sides, those are my bases, and the non-parallel side, those are my legs. Highly recommend writing that on there. So then if this is 65, this is 65, and we know that leg angles are supplementary. So 180 minus 65 would give us 115 for these two angles. Okay, so that's how we would do that problem. I'll erase that in a moment. The next type of problem is using the mid-segment of a trapezoid. Now this one's a little bit more difficult, okay? So we see here that we have a mid-segment, and we know our mid-segment formula. We add up the two parallel sides and divide it by 2. So I know that my mid-segment, QR, and I can even just write it like this, QR equals, if I add up LM plus PN, divided by 2. Now I just have to plug in the stuff I know. I know QR is x plus 2. I know that LM is 4x minus 10, and I know that PN is 8. So I can plug that in there and then put it all over 2. Now I have two options right here. All of these numbers are really easy to divide by 2. So I really could just divide each of these by 2 if I wanted to right now. Or I can multiply this by 2. And I'm going to do that for y'all because it's going to look a little bit different when you get to your problems that you're doing on your own. And it might not always be as easy to divide by 2. So I'm going to multiply everything over here by 2, which gets rid of that 2, which multiplies everything over here by 2. Okay, and I got that 2 from the formula. It's very important to know where I got that 2 in the formula. So now I can say 2x plus, don't forget to distribute, 4 equals 4x, and I'm going to combine these two. Negative 10 plus 8, that's negative 2. Now I can just solve for x like it's any other problem, no problem whatsoever, right? 4 equals 2x minus 2, add 2. 6 equals 2x. Well, x equals 3. So now that I know x equals 3, really I could plug x back in and know that QR equals 5, 3 plus 2. So that's important to understand about mid-segments and how to do those. Let's look at one more example problem, and this is a kite problem. Well, one thing we know about kites is that the diagonals are perpendicular. So automatically I know angle 1 is 90 degrees. Okay? And so I solved this last one with triangle mid. Okay? Not triangle mid, sorry, trapezoid mid. Triangle mid was with a triangle. So I could say right here, different color. I could say measure of angle 1 equals 90, and that was because kite's diagonals perpendicular. Okay, that abbreviation's on there for us. And then if I know that this is 52, well, I could use triangles equal 180 to find angle 2. So the measure of angle 2 using triangles equal 180 Well, 90 plus 52. Let's let it focus. Anyways, this is 52 in here, so I can do 90 plus 52, which is 142, and then subtract that from 180, and I'd get 38 right here. And I use triangles equal 180 to solve that. And then for angle 3, that is simply just thinking about triangles. That's actually just that the triangles are congruent, that it's an angle bisector. So whichever way you wanted to say that, they said it corresponding parts of congruent triangles are congruent. Math Excel likes to call that, let's see if I get the abbreviation right, corresponding parts of congruent triangles are congruent. That's the abbreviation Math Excel uses. So we can write that there. So that's something to think about. Let me see if there's one more example problem I want to go over with you. Nope, that's about it. So that is what 6-6 kites and trapezoids is all about. Please let me know if you guys have any questions at all. Make sure you're staying on top of your work.